So at the time, you can use proposing the theorem is not easy, but using existing theorem, you can actually propose the lemma for special case. So that's another way of writing the paper. Subgraph is a part of the graph. Okay, so this one represents. So when we use, so this one should be defined. V and E. What is a V? V is a set of nodes, and E is a set of edges. What the edges set, what node set. So it's a very important. It's a set. Okay, like the natural number is a set. Otherwise, you cannot actually define the infinite number. So this time we can consider as a set. Then G prime is the subgraph of the G. In case such that the V prime is the subset of the V, and the E prime is a subset of this, something like that. Okay, this is a formal way to define the subgraph. Subgraph is a very important task in graph theory. Why? When you search something, I try to search this subgraph from the big graph, which means you can find a similar pattern. Okay? And also, this subgraph will be used for the basic unit of the processing. So usually the processing entire graph is not easy because it's too big, and also most of the graph, theory graph processing is the NP hard, no optimized. It's a brute force way. So at the time we can use the subgraph matching or subgraph processing. So this is a part of this graph is a subgraph. Then there exists another way to represent such a graph data that includes adjacency matrix, adjacency list, or edge list. So we will see adjacency. Okay. So adjacency matrix means the matrix is M by the M, the matrix M by the nodes. Then we can use N is number of nodes. Okay. So we have the N by N matrix. So for example, when we have a graph like that, so it's a 1, node 2, node 3, node 4, node 5. So we can build a 5 by 5 node and a matrix. Then if 1 and 1 is the same thing, then if they are adjacent connected, 1 and 2 is connected, and 1 and 3 is connected, 1 and 4 not, and the 2 and 1 is connected. And in case of a directed graph, it may be different depending on the direction. And you can build such an adjacency graph. Okay. Adjacency list is you can just for the V1, it has the V2, V3. You can list who are adjacent. That is the list. Edge list is similar, it's the opposite. So depending on the edge, which one is the connected. So they are, it's a 0, it's not the 1. So if V1 is a 0, okay? So in this case, I realize how to erase. It's getting better. So we can put the 0 for the same node. Okay, that is adjacency graph. In my dissertation for my PhD work, I used the adjacency graph for video processing. So this is an example of the adjacency if there is an edge between the node Vi and Vz. Yeah. Okay. usually social media data has social media network has a very, very sparse adjacency graph or adjacency matrix. What does that mean, sparse? Not many one. So think about how many the Facebook user, 1 billion. So we have 1 billion by 1 billion matrix. How many one for each user? So 1 million is the best one, most one? I'm not sure. So usually even more than 100 is very powerful, the Facebook user, right? I have less than 100 still, the user, and sometimes I'm scared to accept the rank sheet. So which means comparing to the total number of users, so it's a very sparse, okay? That decreases the accuracy of your algorithm when you apply the traditional data mining technique. It's very hard to find the characters. It's a very sparse data. That's one of the reasons during the Mohammed, the dissertation, one of the professor asked why you use the 99% of the data for training, only 1% for the testing. I think that one was asked even in the the presentation. That's because of the sparseness of the data. We'd better use more and more the social media data for training purpose. So this is a list. You can just list up the who are connected. You can easily find the most connected one, the V4. That's a simple idea to find the most influential user. The edge list, the opposite. So which one is connected? So there are different types of graph. Null graph, I'm going to skip such a basic, but that should be discussed. If you are writing the paper, you don't have to details. But when you write the textbook or something journal paper, that should be mentioned. Like what is the empty set? Otherwise, it doesn't make sense. Okay. So I'm going to skip that part. Also directed, undirected graph, and mixed graph. Also, you will see a lot of the example in social media data. So about the weighted graph. If you can measure you have the relationship between 4 and 2, relationship 3 and 2. Sometimes it's different weight. Like what if one user has 100 followers, but certain user has 1 follower? That's different to measure. So can we measure such a difference with the weight? That is the weighted graph. Also, sometimes you can use. That's what I don't like for tablet style. So many things I need to connect. So I'd like to carry on easily. That is one of the reasons use the surface, but no. I have another cable and the hard disk drive, and this is for in case the wired network. And also I need to bring the mic. So many different things. So these are all the stuff I need to bring for the tablet. Okay. And so weighted graph. Also nowadays, the user has not just a node entity, just like what you have done in the database. For the entity, you can describe each entity using column. So attribute graph. Attribute graph means even nodes are different. Sometimes you can bigger size and smaller size. That's what I've done in my dissertation to represent each segment, the different size and different color I use. So that is the attribute graph. So you can use the variety depending on the objective. You can use different types of the graph. So multigraph, sometimes it can have the multiple edges. Okay, one is a friendship, another one is the like the how many times the like. Okay, activity measure. So this is an example of the weighted graph. Like in this case, is a distance. In this case, the distance is used for the weight. So then you can easily realize how far between two entities. Okay? But you should be careful. So that's the reason you need to some knowledge on the design or modeling, okay, to characterize such a thing. Web graph, I do not know much about the web graph. So it's a web graph is representing how internet sites are connected. It's an example of the graph for the web, World Wide Web. So World Wide Web are connected by hyperlink, right? So it's I think the multigraph because we may have the multiple hyperlink between two sides. Okay? So these are the part of the example of the web graph for the government agency. Cannot read some of the data. So probably the White House, for example, or the Department of State, and so on. You can use the binary sign to represent whether this one, V1 like the V3, but V1 doesn't like the V2. It's like that. Okay? This is a special case of the weighted graph. We can use the binary. This is very important for to analyze the social media data. And also connectivity in the graph, how much close each other. Then if we can find some entity who are connected very strongly, then we can define such a subgroup as a community or the subgroup, really group, the online community using the connectivity. Okay. So I think during the lecture we have seen some example of the path or some path sequence. So walk means for example, if they are connected, okay, sequence of edges using the sequence of edge or sequence of the V, this is a walk. So open walk. This is an example of the closed walk, right? Walk return to the beginning. Okay. So trail is like the linear. Okay. For example, the visited just one time. Okay. In this case, if we can travel like this one, this is a trail.
But it doesn't cover all the edges, right?
But it covered all the
No.
no. I think you have learned this kind of problem in your math class during the middle school. Whether you can draw, you can visit. There's a well-known problem. I forgot the name of that. So it has the bridge and you can travel. I think there's a similar problem. So this, for example, is a path. The length of the path is you can count the number of edges that you visit. So random walk is so the next node. When we travel next node is the random is selected, or so you can give some condition like the highest weight or something like that. That is called the random walk. Connect. Then can we measure such a connectivity? Okay. So that is the idea of the connectivity, to measure how much strong the node, a set of nodes are connected. So for example, the graph is connected if there is the path. Because they are connected, we can make the path to travel the edges. Okay. Then there are different types of the connectivity, strong connectivity. Okay. If there is, I think that you can understand if you read this one. So this is connected. Definitely, this is not connected because of the weak form. So there is no path to cover all the node. And this one is strongly connected because you can find all the at least the one edges between two nodes. Okay. And this one. Okay. So we connected is the two edges, at least one directed graph is a strong connected. Weak connect is not exist. What is the why is it weakly connected? Figure out before. Why don't you try to understand? But why is it weakly connected?
I think the V1 and the V2 cannot go back.
V1,
V1
V2.
and V2 cannot go back again. Because like if you are in the V5, you cannot go to V1.
To V5. Oh, so it's a
Like
stuck.
yeah.
But here we can travel
Yeah. You can
anywhere. Oh, okay.
Yeah.
I see. That is the weakly connected. That makes sense. Okay. So component means is using subgraph. So we have seen during the clustering, so two part. Okay. So kind of class or cluster of the subgraph. Okay. So we can make the 1, 2, 3. Okay, 3 component. So 3 strongly connected component that can be used for the cluster of the graph. I know. I think that you understand what is the shortest path to cover each and every node. So shortest path. Okay. This kind of technique can be used for what? Network. The network theory. So you can use how many hops for the such a thing. So to measure the size of the graph, we can use a diameter. Diameter is the shortest path to between any pair of the nodes. The size of the path. Okay, then maximum of that.
Question?
Yes.
What does it mean, the longest, shortest path?
Here. So for example, when you have the graph like that, so in this case the diameter can be measured by 1, 2, 3, 4, 5, 6. Okay? That is the diameter. That's the size, longest path to travel. So here to here is 1, here to there. So 1, 2, 3. But here to here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. In this case, 5. 5 is the longest path. That is the diameter. It's not the exact diameter in the circle, but it can be useful to measure the size of the graph. Okay. Then measure the measurement. So this so far we have talked about the. Let's see how many pages did I cover. We have the 40 more. So let's try. So I'd like to finish this one before we have the. So so far we have discussed about the theory,
Is it
the
business?
basic, the definition of the graph,
business.
what kind of graph, and what is the command. Then
Don't forget last week.
the why is the error below? Okay, so next one is the measurement for the structure of the social media network. Okay, so I didn't know that until I see that this side, the cloud. Is there anyone who visited the cloud? It's okay. So, oh, you did? So what is a cloud?
See the most influential.
So influenced measure. So they are not using not only just the social media mining. They consider everything. Then they make the measurement like the 99 is the maximum or 100 is the maximum. Yeah, 100 I think. Yeah. The reason is the 99. There is no perfect person, so it's a 99. So it's a measurement of the Justin Bieber is a 92 and Barack Obama is a 99. Most influential user. Okay. Also, you can, if you have the new algorithm to measure the influence of the social media site, so you apply your algorithm, then also you can compare with your results with this kind of website. Why don't you visit this one? So, Warren Buffett is a 36. Not many people know Warren Buffett, right? So, why do we need? So we'd like to know the influential individual. So one of my students, the Khalid, he is doing the research to find such an influential user from the social media network. That if you are asked to find the influential user, how can you find? Most follower, yes, most connection, most activity. So we can consider many other things, but even though you have the most follower, but your follower actually never retweet. That's not like, so you need the follower who are very active, then it's more powerful. So you can consider many conditions to measure such an influence. Okay, so the one naive way is the traditional way is a centrality analysis. How much centralized? So if we have the one user like this one, and all the other user is a neighbor, then it's an ideal case. So this is the most powerful because it has the most central. And this, even though we can say this graph, this community is most centralized, right? But it's not the real case. Most of the case is like and each other, so it's not easy problem to address. So how can you measure such a centrality? Naive way is you can count. You can consider degree. You can count the number of neighbors, right? You can start from such a thing, and also you can consider many other options. So this is a naive way to count, to consider the degree, which means the number of eight adjacent edges. Okay? There are the others. So also similarity. That's the centrality. The similarity. How much is similar to subgraph or the social user? So if you can, the benefit of the using such a similarity, if you can find the user who are similar as this user, then based on the activity of the similar user, we can suggest. Because each and everyone is different. Also, there might be the pattern. So as I said, the data mining basic assumption is that if it frequently happen, that will be the rule, and that will be the result. So it's the same thing. If you have the similar user, then if you find such a similar, so Amazon use such a thing, Netflix use such a thing, so then it can be used for marketing. The problem is how can you find similar user? We just consider the context, the data structure, which means the same number of the neighborhood, same degree of user, but it's not right. So if I have the 8 follower, so all the users who have the 8 follower is the same pattern? No, it's not. So we can consider some other. So there are different metric to compare the similarity. So cosine similarity we have seen before. The curve the similarity is another one. So vertex similarity. So how much? All of these are anyway based on what? Common, the neighbor. How much common neighbor? Like this one. The denominator is the common neighbor. So also, we need to normalize sometimes. So, for example, if I have the he and me share the 5, the common friend. Okay. However, he has only 5 friends out of 5 is a common friend, but I have millions of friends. So we cannot directly compare he and me are the same. So we need to normalize such a thing. That is a normalization by considering total number. Yeah. Just give the such a part. So normalize the similarity. Okay. So that is the covariance. So how much affect each other. Okay. I'm going to skip some part. So this is a normalized degree centrality, which is based on the number of neighborhood, but that is normalized by what? Depending on the number, depending on the denominator, it's different. Different similarity. Okay. Also, we can consider eigenvector for the centrality also. I do not know much about the cos centrality, but if you are interested in the centrality analysis, you can study more. Page rank is another the popular way to measure the centrality. Okay. Can you explain do you know the betweenness?
Yes.
Yes.
It's like how many does the node, do you know like how many nodes go through one node?
Mm-hmm.
So the node that many nodes goes through this node.
So we
is
try
the
to
highest
find the
security.
such in between.
Yes,
the node.
between the nodes.
Mhm. Okay, that is we are going to use the in between node to
Because the cards and the page rank, it's like an extension from the eigenvector.
eigenvector.
Yeah,
Okay.
extension.
So for example, in this case, then the V2 we consider from this and this.
Yeah.
So this and this. So we
1, 2, 3,
Mhm.
4, 5.
yes, yeah. Then the more we have
Connects.
such a yes, it's connected. That's the idea. So closeness centrality is how much close, okay? So I think the intuitive way, right way. Group centrality
The entire graph.
is to consider the entire graph, okay? The centrality of the groups or the subgraph or graph. Group bigger. You can sum up. Just like this, you can sum up at such a degree. And also you can normalize based on the number of nodes or some others. Okay, so these are the basic of the graph the social media analysis. So if you if you want to know the more about, you can study, or even in your the term project. So those who are using such a social media data can research on the more on that. Then you can explain and why do you use this technique for this problem, something like that. Okay, so after the 10-minute break, we will continue about the discussion about the progress of your project. Then the remaining time we will do the second exercise lab. I don't think we can cover each and every part. Just quickly go over and do some part. Then the most of the missing part will be homework. Then the next class we will focus on the visualization and the social media mining test. Okay. So we will have the break.